Okay, we're moving on to surface area of a cylinder. And again, what surface area is requiring is how much area is on the outside of this three-dimensional figure. Not the inside, which is what volume is. We're working on the outside. How much does it take to cover this can? And so the way you do that is you add up all the areas in this three-dimensional figure. So there's two circles that are identical. So take the area of each one of these circles, area of the top circle plus area of the bottom circle. And then this part in the middle, if you open it up, you flatten it out, it becomes an actual rectangle. So that's kind of what the net for the cylinder looks like. It has a rectangle and two circles. There's a top circle and the bottom circle. And you can think of this like, here I've got a can of corn, and I'm going to take out this paper that surrounds it, and let's see what comes out. And I want you to notice here this distance here. So let me just first take this off, and if I take it out and I flatten it out, you can see it's a can of corn. Let me flip it this way. It's basically a rectangle, and that's what we've got. So the surface area of a cylinder is going to be the area of the top circle, the bottom circle, and this rectangle. So one thing I want to show you here is that's really important is that for this can of corn, you notice it has, here's one of the circles. It doesn't matter if it's top circle or bottom circle. But this distance here, if you look at remember the distance around the circle, it's called the circumference. So the distance around the circle is called the circumference. And it also happens to be one of the dimensions of this rectangle. So here I'm unrolling, taking the can out. Here's the distance that was around the can. When I open it up, it actually becomes kind of like the base. The distance, so the circumference of the circle of the top or bottom area of the can is also the base or the width of your rectangle. All right, so let's take a look at that. Here I've got a little drawing for it. This distance here around the circle is the same distance as this. So if you can imagine taking this rectangle and wrapping it around the circle, they're the same distance. So the circumference of the circle is going to be, the base, and here we have the height. All right, so let's see how we calculate this. First, let's take the area of these circles. And remember, the formula for area of a circle is pi times r squared, or pi times radius. And we're going to just put in the numbers here for that. So we notice here our radius for our can is, or whatever this problem here is, 3 inches. So radius equals pi, which is 3.14, times radius, which is 3. And it's radius squared, so 3 times 3. There, we need 2 of those, 3 and 3. And if we calculate that, we get area equals 28.26. And that's just for one of the circles. So area of the top circle is 28.26. And fortunately, we know that the area of the bottom circle, even though they're not really drawn to scale here, is going to be exactly the same. If you look at the can, the top circle area is going to be exactly like the bottom circle area. All right, so we'll use this number twice when we add up the entire thing. So we already have 2 of them, area of top circle, area of bottom circle, right here. We need area of top circle and area of bottom circle. Now let's look at the area of the rectangle and how we're going to calculate that. So the thing that we notice is we have this distance here, the 8 inches. That's height. So remember, the area of a rectangle is basically base times height. The area of a rectangle is base times height. That'll give us this area here. And so we have the height, it's 8. And now this distance here is going to be the same distance as the circumference of the circle. And remember, with calculating circumference, it's pi times d, or the diameter. So pi is 3.14, and then diameter for our circles is going to be 6, because remember, diameter is just 2 radiuses. So 3 plus 3 is 6, and that's our diameter. So pi times the diameter is the circumference of these circles, which also now is the distance here that we need to calculate the area for this rectangle. So that's the base, which is the circumference of the circle, which is pi times d, and the height. And here it's 8. Okay, so 8 times 3.14 times 6 is 150.72. So now I have all 3 of my areas, and I just add them up, and I get area of the top circle, area of the bottom circle, and area of the rectangle. And together they become 207.24 inches squared. And again, we're using area, so we need square units. And that's how much it would take to calculate the outside of this can.